चलो ఏం చేస్తున్నాం ఇప్పుడు ఎక్కడ దాకున్నాం ఫ్రెనల్ డైఫ్రాక్షన్ అయిపోయింది కదా
Practical explanation of that.
ఓకే ఏం రాస్తాం మనం ఫ్రెనల్ ఎక్స్ప్లెనేషన్ ఫస్ట్ ఏంటి స్ట్రైట్ ఎడ్జ్ then మళ్ళీ then point source is placed in the path of straight edge. When point source is placed in the path of straight edge. Okay. We observe bright brightness opposite to edge and the illumination gradually decreases. Illumination gradually decreases. Okay, beyond straight edge. Gradually decreases beyond straight edge. And alternate dark and bright fringes observed in illuminated region. As shown in figure. Okay. Now, what he is telling, this is like a pencil or pen something, is a point source. Light coming from point source, incident on straight edge. This is the spherical wavefront. So when it is striking, spherical wavefront is striking the straight edge. What happened exactly opposite to that? Intensity of light gradually decreases like this, and alternate bright and dark fringes are observed like this. Okay. So this is actually practical observation. So this practical, what is that? When a point source is placed in the path of a straight edge, very straight edge, we observe brightness opposite to edge and illumination gradually decreases beyond straight edge like this, and alternate dark and bright fringes are fringes observed in the illuminated, means the straight edge is obstructing this area, but this area no obstruction. So this is the illuminated area. So in the illuminated area, you will observe alternate bright and dark fringes like this. Okay? Alternate dark and bright fringes are observed in the illuminated region as shown in the figure. Like this you will observe. Okay? So this is, he is explaining. This is a practical observation. How he explains. Listen. Hirasara?
Yes, sir.
Now. Beyond straight edge. Beyond straight edge means this is the straight edge, beyond means this area. Like this. So this is a straight edge. Beyond straight edge with this. So what he is telling? My explanation is here. In this region, okay.
Sir, can you
Okay. Huh? Okay, na?
Yes, sir.
So beyond straight edge means this area. So in this region, the amplitude of light gradually decreases. Amplitude of light gradually decreases. Okay? Because amplitude is inversely proportional to R. So as you are going like this, distance gradually increases. Amplitude is inversely proportional to R. Okay, that's the one thing. Inka. So amplitude gradually decreases, and 1 plus cos theta, amplitude proportional to 1 plus cos theta also what? Decreases. Why? As you are going down, what happens now? See, this is theta, and like still you are going with theta still increases. As you are going down, theta increases. So amplitude proportional to 1 plus cos theta as well as this. R increases, see, this is R. So as you are going down, R is increasing. So amplitude will decrease. And as you are going down, this theta also increasing. When theta increases, for higher values, cos value decreases. Cos 60 is less compared to cos 30. समझ गया ना? Cos 60 कितना? 1 by 2, 0.5. Cos 30, root 3 by 2, 0.86. So as you are going down, theta increases, cos value decreases. So amplitude decreases. Okay. Huh? Thereby intensity also decreases. Why? Because amplitude intensity proportional to amplitude. So in amplitude decrease, intensity also decreases. B. Now in a illuminated area, this is the illuminated area. Okay. If at a point, bright fringe in illuminated, if at a point bright fringe is observed due to contribution of odd number of half period zones. Odd number of half period zones. See, here you are getting, for example, here you are getting bright, here bright, here bright. So bright means here, that is A resultant is A1 minus A2 plus A3. See, A2, A1 cancel, but A3 will be there. So at a point where odd half period zones contribute amplitude means, so resultant amplitude is there, intensity also there. That is the reason it will not become zero. So there is some amplitude is there, some brightness is there. This is the bright spot. Okay.
Sir, once can you read out the B point, sir?
At a dark point, you look at dark. Okay. And here dark, here dark, here dark. At a dark point, even number of half period zones contribute at a dark point, even number of half period zones contribute. Okay. Such that what is that resultant amplitude is what? A1 minus A2 plus A3 minus A4. If even number is there, this is cancelled by this is cancelled by this. You will get almost a zero. Like that. And a dark spot there, even number of half period zones contributing the amplitude. Bright spot there, odd number of half period zones. Okay. So like this, you will get alternate dark and bright fringes. Right?
Sir?
Ah.
Sir, once can you read out the second point, sir?
Yeah.
Yes, sir.
In illuminated area, this is illuminated area. If at a point, bright fringe is observed. Bright fringe is observed. Okay, due to contribution of odd number of off-period zones. ఇక్కడ బ్రైట్ ఫీల్డ్ అంటే ఇక్కడ ఏమన్నాడు ఆడ్ నంబర్ ఆఫ్ ఆఫ్-పీరియడ్ జోన్స్ అంటే A1 minus A2 plus A. Odd అంటే these two cancel, this is there. So at a dark point and a dark point, at a dark point, even number of off-period zones. అదే బ్రైట్ దగ్గర ఆడ్, ఎందుకంటే ఆడ్ అయితే రెండు క్యాన్సిల్ అయితే ఇంకోటి మిగిలిపోతుంది. డార్క్ అయితే హాఫ్ పీరియడ్ జోన్ కంట్రిబ్యూషన్ డ్యూ టు even number of half period. Even at a 4, 6 like that, they get cancelled like this. You will get 0. అది వాడు చెప్పింది. ఎవడు చెప్పిండు? ఫ్రెండల్ గారు. ఓకేనా? ఏమైంది ఇది? ఈ వీక్ ఏముంది? ఓన్లీ డైఫ్రాక్షన్. Coloration కూడా ఉందా?
Only diffraction. Only diffractions.
No. Circular aperture. Diffraction due to circular aperture. See, circular aperture అంటే now if a point source is placed in front of, okay, small circular disc, directly bead. Do you know bead? If a point source is placed in front of a small circular disc, beyond disc, alternate dark beyond disc, a bright spot is observed. A bright spot is observed. surrounded by alternate dark and bright fringes. Alternate dark and bright fringes. Like this. Now, this is the circular disc. Okay. In the path of this, you are placing a point source. Okay, you observe here. Now here you will observe. Here you will observe.
सर थोड़ा कैमरा इधर करो.
Okay. Now, exactly opposite to this, you will observe. You will observe the bright spot here, exactly opposite, surrounded by dark and bright. Like this, you will observe. So, exactly opposite this, you are placing a point source. And light falls on this. Okay. Light getting actually diffracted and forms a bright spot. Like this. Alternate dark and bright fringes. You will observe. This is practical observation. So, explanation. How is explained? So, due to diffraction, okay, due to diffraction of waves around edges, okay, a bright spot is observed. Because these light waves will combine here. Bright spot is observed. Okay. And alternate dark and bright fringes. Bright concentric fringes are observed due to superposition of odd or even half period zones. What I want to say here, exactly behind this disc, the diffracted, the waves which are striking here, they will bend and they will combine here. They bend and they combine. But surrounded, you are getting dark and bright fringes due to superposition of odd and even half period zones. So wherever odd combination is there, you will get maximum. Wherever even combination is there, you will get minimum, like this. Okay? This is due to circular aperture. So this is what the diffraction due to what? Fresnel. Yesterday I have given Fresnel theory. What is meant by half period zone? What is the width? What is the radius, area? Okay, and this. This is completely about Fresnel. Now we are going to start Fraunhofer. Fraunhofer diffraction. Right? Fraunhofer diffraction. Okay. So, what is the Fraunhofer diffraction? I told Fresnel and Fraunhofer comparison. Okay. Now Fraunhofer diffraction. What is the Fraunhofer diffraction? See. In the case of Fraunhofer diffraction, what happens? Comparison difference. Fresnel and Fraunhofer. First statement.
Yes, sir.
Difference. Okay. This is single slit. And this is very much in the syllabus. This is, they will give, this is an extra syllabus, but they will ask in the exam. That also I completed. Okay. So now this is very much in the syllabus. This is only main Fraunhofer diffraction due to single slit. Okay. Sure. When, okay, when a point source,
Excuse me, sir. Excuse me, sir. What is the heading, sir?
Fraun, Fraun, Fraunhofer, Hofer, Fraunhofer.
Actually, that is not available, visible in the camera, sir.
Okay. Now
Yes.
Yes, sir. It's not.
it's okay.
Yes, sir.
Fraunhofer diffraction. Okay. Now he will explain single slit. What is that? When a point source S, when a point source S is placed in front of convex lens. When a point source S is placed in front of convex lens. Okay. Convex lens at the focus. with the focus. Parallel beam strikes. Parallel beam strikes. Okay, single slit. Parallel beam strikes single slit. This is like this. Here you have got a point source. Here you are placing a convex lens. Light will come from this point source, will strike this point source like this. This is a point source, this is a convex lens. You are placing the point source where it focal length. Then emergent beam will be parallel beam. So parallel beam will come and strikes this slit. Okay. Now this is the screen. So these particular rays, what is the nature of wavefront? Because parallel beam ante nature of wavefront planar, kada?
Yes.
Yes, sir.
So parallel beam strike a single slit or planar wavefront. Planar wavefront strikes this slit. Okay. Planar wavefront M.
So why are we using a convex
Huh?
lens?
Planar wavefront N. Okay. Strikes a planar wavefront N. Okay. Strike a single slit of width A. What is the single slit of width? This is A width. Okay. And diffracted around edges means ikkada. Okay, edges to get diffracted beam on screen. We get diffracted beam on screen. Another convex lens. Okay, is placed after slit. You are placing here. So another convex lens is placed after the slit. Okay. Here. So these waves, parallel beam strikes like this. Some of the rays, these are diffracted like this. So the rays which are striking parallel, they will be gets focused here. Correct? And you will observe a central maximum like this. You will get central maximum. Okay. This is the central maximum. And you will observe alternate bright and dark like this. Gradually decreases. There are alternate dark, bright and dark like this. Alternate gradually decreases. This you will observe. So he is explaining this. Who? Fraunhofer. So to get diffracted beam on the screen, another convex lens is placed after the slit. Okay. So what is the distance between this convex lens and here? This is the focal length f2 or focal length capital F. This is small f. So they converges here. Okay. Now close. Now put at center of screen, that is opposite to slit. Opposite to slit here. Almost path difference here will be whatever the distance traveled by this ray here and here. There is no path difference because all this ray travel same distance before reaching the lens. Before striking this lens, the distance traveled by the this ray from here to here, from here to here, same. So once they strike the lens, the duty of the lens to converge, and you will get central maximum like this. So at the center of the screen, opposite to slit, path difference is 0. So phase difference 0. Path difference is 0. Phase difference 0. Correct? Here. Thereby we get central maxima. Yeah. We get central maxima. Govinda? Very central maximum. Okay. Now, here, then what happens now? Here. So now behind central maxima, we observe alternate dark and bright fringes. We observe beyond central maxima. Beyond central maxima, we observe alternate dark and bright fringes. No explanation. For dark, how you will get the dark? See, you take some point here, some point P. Now where you are getting the dark here? This is a dark. Here. Okay. You are getting the dark here, and here these are the two. Now what is the path difference for the dark at this point? Path reference kaisa karna? You draw a straight line like this. Like this. Which makes a 90 degrees on this. And this is what is this is? Wavefront. What wavefront? Huh?
Planar.
Array. ये नहीं दिख रहा?
दिख रहा सर.
Beyond central maxima, okay, we observe alternate dark and bright, dark and bright. He is now explaining why you are getting dark here. So here we are creating a path difference between these two waves which are reaching here. So for the dark, we are calculating the path, what here this thing. How? This is the slit. What is the slit with the Mn? Now you are drawing it, this is. What is this angle line to this? Okay, you are drawing from the M a line perpendicular such that it makes 90 degrees. This is the ray. Okay. MNQ. This is Q. So what is the path difference there? This is theta. So draw a perpendicular line from M on what? NP. Okay. NP. NP or NQ? NQ. Such that NQM is 90. NQM is 90. Here is 90. Okay, and NMQ is theta. This is theta. Okay, and here NQ is equal to delta x. Delta x and then path difference.
Different.
So what is that? In triangle MNQ sin theta. Opposite side ante NQ. By hypotenuse ante opposite 90 kada MN. So this is delta x by MN ante ఇది A. Slit kada ఇది A. Hello? Dark తీసేసి అక్కడ ఏం రాస్తారు? పాత్ రిఫరెన్స్ రాయండి. ఇప్పుడు డార్క్. దీన్నే డార్క్ ఏమంటారు? మినిమా అంటారు. Okay. Now tell me. ఇంకా అవును. You can draw one more line from the center to the point B. Kada? which makes an angle same angle theta. ఇక్కడ నుంచి ఇక్కడ distance center. This is center, ఇది O. This is center of the screen O. Center of the slit ఏమందాం? పేరు పెట్టాలి కదా, పేరు పెడదాం O dash. ఓకే, ఇప్పుడు ఏంది లైన్, లైన్ ఏంటి O dash P makes an angle theta with O dash O, thereby tan theta. Tan theta is opposite side, OP by O dash O. Right? Vanessa? Okay. Now let OP and this OP. Let OP equal to Y. Y and the distance of nth bright or dark from center of screen. జాగ్రత్త రాయండి, మీ పుస్తకాలు సరిగా ఉండదు, తొందరవద్దు, కంగారు పడద్దు. So tan theta is OP by O dash O. What is the OP? This is OP. This is Y. This is Y by O dash O ante ikkada. O dash O ante this is F as well as D. D ante distance between slit and screen. Of course, D and F approximately equal. So this is Y by D. Where D is what? D is distance between
Slit and screen.
Between slit and screen. Okay?
So move camera downwards.
ఇది tan theta, ఇది sin theta. ఓకేనా? ఇది ఈక్వేషన్ 1, ఇది ఈక్వేషన్ 2. Right? ఈ ఫిగర్ వేసిరా?
So time is
అయిపోయింది. ఈక్వేషన్ 3 ఏంటి? ఇక్కడ రాయండి, ఇది ఒకటి రాస్తే ఈక్వేషన్ 3 ఇక్కడ రాస్తున్నా. If theta is small, tan theta equal to sin theta.
Good evening.
Tan theta is y by d. Sin theta and delta x by a. So y equal to delta x into capital D by a. This is third equation.
So camera ni కొంచెం కింద కన్నారా
Huh?
కెమెరా ని కొంచెం కింద కన్నారా
కిందికా కనబడుతుందా?
ఎస్
ఇది రాసి రేపు టుమారో విల్ కంప్లీట్ ద సిలబస్. రేపు అయిపోతుంది. These both we equated. అంతే.
Thank you, sir. Bye, sir.